So this is Pascal's triangle. We're going to use this to expand binomials. First we have to see the pattern in Pascal's triangle. Maybe if you're trying to think what the next line would be here, maybe you could see the pattern of 1s on the outside. Maybe they have a 1 out here. 1, 2, 3, 4, 5, 6. Maybe you see this would have to be a 6 there. 1, 2, 3, 4, 5, 6. Maybe you see this pattern, 1, 3, 6, 10. Add 2, add 3, add 4, add 5. Maybe that's a 15. Same thing here, 1, 3, 6, 10. Add 2, add 3, add 4, add 5. Maybe that's a 15. It's hard to see what number might go here. It's not an easy pattern. 1, 4, 10. That's weird. So maybe you have trouble finding the pattern. The easiest way to see this pattern is this way. 1 plus 1 is 2. 1 plus 2 is 3. 3 plus 1 is 4. 3 plus 3 is 6. 4 plus 6 is 10. 10 plus 10 is 20. So 20 is the number that does go right there. That's the number we were having trouble with. And then you can keep going from there, right? 6 plus 15 is 21. You get the next row. 1 plus 6 is 7. That column, that row is always 1 there. And you can keep going and figure out the rest of this. 15 plus 20 is 35, etc. And figure out the next row. Now, why do we have Pascal's triangle? Well, I want you to see a pattern here. Again, math is all about patterns. Anything to the 0 power, well, except 0, is 1. It's interesting. 1 matches 1. Okay? Coincidence? X plus 1 to the first power is x plus 1. I'm going to highlight the coefficients and constants there. The coefficient is 1 and the constant is 1, 1, 1. Ooh, interesting. Very interesting. If you were to multiply this out, what I mean by that is it's a binomial times a binomial. So x plus 1 times x plus 1 using distributive property. Some people use the FOIL method. You get x squared plus x is plus 2x plus 1. Highlighting the coefficient and constants there, there'd be 1, 2, and 1. 1, 2, and 1. It's almost like this is linked to this one. This is linked to this one. This is linked to this one. See if that would happen for the next one. The next one would be x plus 1 to the third power, which is really x plus 1 squared, which is that, x squared plus 2x plus 1 times another x plus 1. So you have to kind of clam that guy, multiply it out. If you distribute everything, you get x cubed. Let's see, 2x squared plus x squared is plus, it's to the third power there. That's 3x squared. 2x times 1 plus x is plus 3x. And then 1 times 1 is plus 1. Just to highlight the coefficients there, that would be 1, 3, 3, 1. You see, this goes down by 1. 3, 2, 1, 0. And that, wow, that looks a lot like this one. 1, 3, 3, 1. Right? So rather than multiplying out the next one, like whatever x plus 1 times x plus 1 times x plus 1 times x plus 1 to the fourth, I'm just going to write the coefficients of that row. Let's see, that would be this row right here. So I'm going to write the coefficients 1, 4, 6, 4, 1. And it's going to be x to the fourth power to start with, x to the third power here, x squared here, x here. I could write x to the 0 here if you want. This is going to be plus and plus and plus and plus. Of course, x to 0 is really what? It's really 1, so I don't really have to write that. And that's my expanded x plus 1 to the fourth. So we are expanding binomials. This is a method called Pascal's triangle of expanding binomials. It's really kind of a neat little method. Let's try it with something a little bit more complicated. Everything gets more complicated in Algebra 2, right? By the way, look back at that and see the pattern here. So 0 power is the first row. first power is the second row, second power is the third row, third power is the fourth row. So it's always, the row is always one more than the power. So keeping that in mind, this is second power. So to get second power, I need the third row. So I'm going to circle this row. These are the numbers I need. The coefficients are going to be 1, 2, and 1. Now I like to think about the a term is going to be to the highest power here. This is second power, so it's going to be a squared, and then a to the first, and then a to the 0. We might simplify that in a second, but that's the idea. The b squared is on the back end, so this is going to be b squared is the highest power of b, then b to the first, as the pattern goes that way, and then b to the 0 power. And there's pluses in between. We know b to the 0 power is just 1, so this is going to be just a squared plus 2ab plus a to the 0 is just 1, so this is going to be plus b squared. So I've used the formula to expand a plus b squared rather than actually multiplying it out. You might say, well, I could have just multiplied that out faster, maybe, but what about this one? A plus b to the fifth? Well, I think we can do this a lot faster using the method. So fifth power, that would be the sixth row. 1, 2, 3, 4, 5, 6. That's the sixth row. I'm going to leave myself a little more room here. Sometimes it's nice to leave yourself some room when you do this. So I'm going to write these coefficients out to the side here. 1, 5, 10, 10, 5, and 1. And I'll go to the first term first. So this is a. So a is going to be to the fifth power for the first term, the very highest power it can be. Then a to the fourth. The pattern just kind of works like that. A to the third, a squared, a to the first, a to the 0. I'm not going to write a to the 0, but it's there. And then working backwards, b is to the highest power at the back end, b to the fifth, b to the fourth, b to the third, b to the second, b to the first, and b to the 0, which is really 1. I don't need to write that. And so those are all positive in that case. And so now we have a little bit more difficulty here, and that's now expanding that. Wow, that really saved a lot of time there. You can see how this is a nice little method to use. Let's try it with a minus sign. So this gets a little bit tougher. So when you do this, so let's figure out which row we're talking about here. So this is third power, so 1, 2, 3. The fourth row are the numbers I'm looking at here. So it's going to be 1, 3, 3, and a 1. So the first term is x to the third power. So how it's going to start. So x to the third, x squared, x to the first, x to the 0. Now be careful, -2 is the second thing. So I'm going to put this in parentheses. I'm going to start on the back end. That's going to be to the highest power. -2 in parentheses to the third power. -2 in parentheses to the second power. -2 in parentheses. These parentheses are really important here. And then -2 to 0 is just 1, so I don't need to write that. Okay, now let's simplify these terms here. So the first term would just be x to the third. -2 times 3 is -6. So I'm going to write -6x squared. -2 squared is a positive 4 right there. 4 times 3 is 12, so plus 12x. -2 times -2 times -2 is -8. -8 times 1 is -8, so -8. So you can see now the signs alternated here. Because that's a -2, there's a minus sign. The signs actually alternated in that case. So you do have to be careful when you have a negative in there that you include it and use parentheses so that when you square it or put it to an even power, it's going to simplify nicely to a positive number. Try a little tougher. So very similar format though. Fourth power, look at the fifth row. Let's see. 1, 2, 3, 4, 5. So this is the row I'm concerned with. Those are the coefficients I need. Again, I'm going to give myself a little more room. So 1, 4, 6, 4, 1. So let's take the first term. Oh, that's 2x. So in parentheses, I'm going to put 2x to the highest power, which is fourth power. Then it's going to be 2x to the third power. then 2x in parentheses to the second power, 2x in parentheses to the first power, and then 2x is 0. And here we have negative 3. So on the back end, we have negative 3 to the fourth power, negative 3 to the third power, negative 3 to the second power, negative 3 to the first power, using parentheses every time, negative 3 to the 0 power. So now we're just going to simplify these terms. Right now there's a plus sign, but I have a feeling some of this is going to work out. So 2 to the fourth, 2 times 2 times 2 times 2 is 16. 16 times 1 is, this would just be 16x to the fourth. This is a negative 3 times 2 to the third, so times 8. So negative 3 times 8 is negative 24. Wow, this is getting tough to do in my head. Let's see, negative, so 8 times negative 3 is negative 24. Negative 48, negative 96. So minus 96x to the third, plus, this is going to be a positive number, 9 times 2 times 2 times 2 squared. 9 times 4 is 36. 36 times 6, I need to do that here. So this would be 3 and 18 is 216. So plus 216x squared. And this is negative 3 to the third, which is negative 27, times 2 is negative 54. 54 times 4, 6 and 1 is 21. Is that right? 26, okay. So we get minus, because that's a negative there, 126x, and then negative 3 to the fourth is negative 3 times negative 3 times negative 3 times negative 3, which is positive 81. And so we get our expanded binomial. Whew. Wow, some big numbers there. Hopefully I multiply those correctly. I guess you could check in your calculator if you're not sure on that kind of thing. I think you're getting the idea here. If we have time for this one, last one, this would be 6 power, so 1, 2, 3, 4, 5, 6. Uh-oh, I need the next row. 1, 6, 15, 20, 15, 6, and 1. So you want to leave yourself as much room as you can here. But all those coefficients, 1, 6, 15, 20, 15, 6, and 1. So 2 to the highest power, so this would be 2 to the 6th times 2, multiplication, 2 to the 5th times 2 to the 4th times 2 to the 3rd times 2 to the 2nd, there's a times sign there, times 2 to the 1st times 2 to the 0, which is 1, and negative x to the 6th. So this would be in parentheses when it's negative especially. Negative x to the 6th, parentheses negative x to the 5th, parentheses negative x to the 4th, parentheses negative x to the 3rd, negative x to the 2nd, negative x to the 1st, and negative x to the 0. And then it's just a matter of simplifying this out. 2 to the 6th, I think that's 64. Everything's going to be in reverse order here, that what I normally want. This would be minus 2 to the 5th is 32. 32 times 6 is 12. So 1 is carried 18, 19, 192. So minus 192. X, there's a minus there. That's where that negative came from. Plus for this one. Let's see, 2 to the 4th is 16. 16 times 15 would be 0, 3, 8, 6, 1, 0, 4, 2. 240, so plus 240 x squared. I think you're getting the idea. I would keep going through that, but the screencast is over, so I'm going to stop and you can do the rest of that one on your own.